Hello, dear listeners. I am Alexander Voronin, Chief of Department of Chemistry, Samara State Medical University, Russia. I present to you the research Metrological Trends of Forensic Toxicology. The approbation of quantitation procedure on biological matrix similar to routine samples with measurement limit of detection and limit of quantitation concentration range, as well as reproducibility, selectivity, and recovery is a main requirement in forensic toxicology. These requirements are important stages of full-fledged realization of quantitation procedure for analysis of biological samples by expert chemists. In Russian Federation, there are standards of good laboratory practice that regulate quality assurance of clinical laboratories and forensic toxicology laboratories. There are no regulatory documents in forensic toxicology that define the procedure for measurement metrological characteristics of analytical procedures. Purpose of this research is comparative estimation of metrological characteristics of various quantitation procedures in forensic toxicology on example of quantitation verapamil in blood samples. This slide shows structural formula of verapamil. It is a phenylkylamine derivative. Verapamil is a basis nitrogenous drug, is a tertiary amine. We used reference material of verapamil of LGC standard. The concentration range of verapamil in blood samples was from 100 to 5000 nanogram to milliliter, 14-layer chromatography with video densitometry, and from 5 to 150 microgram to milliliter for UV spectrophotometry. Preparation of blood samples was done by liquid-liquid extraction. Blood sample quantity was 10 milliliter. Extraction parameters are chloroform at pH value from 9 to 11. For UV spectrophotometry procedure, quantity of blood sample was increased to 50 milliliter. From an aliquot of 20 milliliter chloroform extract, back extraction was made with an acid hydrochloric solution of concentration 0.1 mol to liter. To identify verapamil in blood samples, the method of gas chromatography mass spectrometry was used. TLC parameters of verapamil analysis are shown on this slide. Used polar systems for basis nitrogenous substances. Detection was done with Regendorf reagent and by use UV light. For video densitometry, obtained chromatograms were scanned, saved as JPEG files, and processed using TLC Manager software. In UV spectrophotometry, analysis of verapamil absorbance of back extract from chloroform extraction obtained with a hydrochloric acid solution was measured. The absorption spectrum of back extract was recorded in the wavelength range of 200 to 400 nanometer. Principal peak of UV absorption spectrum is 277 nanometer. Measurement limit of detection and quantitation range, trueness, repeatability was done in accordance with guidelines for validation of analytical methods used in forensic toxicology. Test guidelines is in recommendation status. It is optional. Analysis procedure of verapamil in blood samples included two stages: GCMS screening in scan mode and subsequent quantitation by methods with a lower level of selectivity, TLC with video densitometry or UV spectrophotometry. Application of these methods for quantitation allows to reduce the load on GCMS systems as well to reduce time and economic costs of these analyses. The measurement limit of detection of verapamil model blood samples were analyzed in the concentration range of 100 to 5000 nanogram per milliliter. When measuring limit of detection, we used visual registration of the processed image of TLC plates. For image processing, we used TLC Manager software. Limit of detection of verapamil in blood samples was 150 nanogram to milliliter or 1 microgram in spot. Matrix effect was estimated by analysis of blank blood samples. Chromatographic zones were not detected on the plates in the range of RF values from 0.2 to 0.8. Determination of dependence of analytical signal chromatographic zone area on the analyte concentration showed that when verapamil amount is more than 5 microgram per spot, there is a deviation from linear function. For verapamil, calibration function is polynomial, quadratic. Limit of quantitation was 300 nanogram to milliliter. Concentration range in which it is possible to perform quantitation is from 300 to 5000 nanogram to milliliter. For UV spectrophotometry, absorption peak in spectrum were recorded for extract with a verapamil concentration 5 microgram to milliliter. Analytical wavelength was 277 nanometer. Linear range of dependence of absorption on concentration, which was from 10 to 160 microgram to milliliter for solution to sample cell obtained from a reference material of verapamil. Correlation coefficient is 0.998. For blood samples, a limit of quantitation was 6 microgram to milliliter. Concentration range was from 6 to 100 microgram to milliliter. To assess trueness and repeatability, blood sample of verapamil free concentration levels were analyzed within the range of each technique. Relative error of verapamil blood concentration, estimation of method trueness, measured by TLC with video densitometry for all concentration level did not exceed 20%. By UV spectrophotometry, trueness was measured for higher concentration. Relative error for upper and middle concentration levels is 22.7% and 27.5% respectively. Repeatability of result of verapamil quantitation by UV spectrophotometry at all concentration level did not exceed 7.4%. By TLC with video densitometry, Result dispersion was decreased from 24.3% for lower concentration level to 5.8% for upper concentration level. Concentration range of verapamil in blood samples by TLC with video densitometry, phytotoxic level, and little level concentration. UV spectrophotometry allows quantitation of verapamil in blood samples only in case of lethal poisoning associated with a high concentration of native verapamil in blood, more than 6 microgram to milliliter. In a model experiment, a comparative estimation of metrological parameters of TLC with video densitometry and UV spectrophotometry for quantitation of verapamil in blood samples was made. The use of video densitometry for processing chromatograms in TLC method made it possible to quantitate verapamil concentration in blood samples at a lower level compared to the range of UV spectrophotometry method. Thank you for attention.